Hello everyone, my name is Duyck and I greet you from Ghent University, where I have done my PhD in mobile wireless communications. In mobile wireless communications, we all know the current systems like GSM, Wi-Fi, 3G, 4G, satellite communications. A transmitter tries to convey information such as video or audio towards a receiver in the formats of bits. In my PhD, I tried to maximize the quality of communication while minimizing the cost. An important quality metric is the error probability. For example, when I transmit a photograph to my friend, I want him to properly receive the photograph. Instead of this erroneous photograph, I want him to receive a good photograph with all the bits correctly received. Other metrics in wireless communications is, for example, the rate. For example, the number of megabits per second at which we can transmit, which will determine whether we can transmit high definition videos or not. And this, while we try to minimize the error probability and maximize the rate, we try also to minimize the cost of communication, which is mainly determined by the complexity of the device and the channel quality it can handle. Now, the fundamental limits of such a communication system are determined by letting the complexity go to infinity and then seeing which rate and error probability we can achieve. This can be done theoretically on paper. It's a mathematical derivation. Now, in wireless communications, it especially suffers from a bad channel quality. The quality of the channel is so bad because of destructive interference of the electromagnetic waves at the receiver. Now, the way we solve this in wireless communications is by repeating or replicating information over time, frequency, or space. For example, this wireless router here has, instead of only one antenna, it has two antennas. Actually, at our homes, the computer screen has multiple antennas, the wireless router has multiple antennas, and this is how we achieve diversity, which is a way to solve the problem of bad channel quality in communications. Now, the focus of my PhD was error-correcting codes, which is an efficient way of achieving this diversity in the sense that it allows to approach the channel limit, the fundamental limit of the channel, very closely. So after designing good error-correcting codes for such systems, we even extended them to future wireless communication systems such as 5G, where we let multiple transmitters cooperate between each other to improve their error rate performance. After in theory designing such schemes, we tested them in practice in our lab, where we have this setup here, where we let multiple small transmitters collaborate between each other in order to improve their error rate performance. So our algorithms can be used in practice by operators, for example, as follows. In 4G, operators will place antennas more closely to each other and multiple devices will collaborate with each other, and then they can use our algorithms to achieve a better quality of communications.